Hello Year 8, it's Miss Fisher here. I've put a do now task on the board for you. Please complete this in your exercise books. Pause the video and have a go. Here are the answers to your do now. The 8 energy stores are shown on the next slide, but can be remembered using kilogram cement. A vaccine is a dead or inactive part of a pathogen. Energy is transferred between stores via pathways, and in a chemical reaction, the atoms are rearranged to make new substances. The 8 energy stores are kinetic, gravitational potential, chemical, elastic potential, magnetic, electrostatic, nuclear, and thermal. In today's lesson we will be focusing on the energy pathways, so the ways in which energy can be transferred from one store to another. Quick recap of the 4 different energy pathways that we remember using the Mr. He mnemonic. M stands for mechanical work done. R stands for radiation, of which light, sound and infrared are examples. H stands for heat, and this can be via conduction or convection. And E stands for electrical work done, or current. So, we had a quick look at mechanical work done just before the end of last term, but just to remind you, that energy can be transferred mechanically when an object moves or when the motion of the object changes, i.e. when a force is applied. Pause the video here and see if you can think of any examples where energy is being transferred mechanically. Some examples of mechanical work done are shown here. When an object falls or moves, mechanical work done causes an increase in the kinetic store of the object and the thermal store of the surroundings. When something moves against friction, like the wheels of your bike on a path, mechanical work done causes an increase of both the thermal store of the object and the surroundings. So, during mechanical work done, a transfer involves energy being transferred by mechanical work involving one of the following. So either an object is changing speed, an object is changing direction, or an object is changing shape. The next type of energy transfer is the radiation pathway. In this transfer, the energy is carried in waves that have no mass. And there are 2 kinds of waves that have no mass: sound waves and electromagnetic waves, including visible light, so the light which we can see, infrared light, which we cannot see, this is how our television remotes work, X-rays and gamma rays. Energy can be transferred from the sun by radiation to the earth. Our sun gives off all waves of the electromagnetic spectrum. The visible light allows us to see things, and the ultraviolet and infrared waves warm the earth. The third pathway is the heat pathway. Some objects are hotter than others. Like my cup of tea is warmer than the air around it, and the energy is always transferred from the hotter object to the cooler object. So if I leave my cup of tea on my desk while I'm planning your next lesson, the thermal energy in my hot cup of tea will be transferred to the thermal energy store of the air around the cup by the heat pathway. There are 2 ways in which the heat pathway works. For energy to be transferred, there needs to be particles which move by either conduction, which works in solids, or convection, which works for liquids and gases. In conduction, the energy is transferred by direct contact. So this would be like me touching a really hot metal saucepan. The heat would be transferred from the saucepan, the thermal energy would be transferred from the saucepan to myself by conduction, whilst the thermal energy in my tea is transferred to the air by convection, because it's from a liquid to a gas. Metals are really good conductors of heat because they are usually solids, whilst non-metals are not as good at conducting heat. And gases are even worse, they are very poor conductors. And poor conductors are called insulators. The final way that energy can be transferred between energy stores is the electrical work done pathway. Energy is transferred when an electrical circuit is complete. This electrical work is also known as current. An electrical circuit can be as simple as some wires, a battery and a bulb, or it can be as complicated as our nervous system. This is where our brains rely on electrical work done to send signals to the rest of our body via our neurons and our spine. Metals are all good conductors of electricity because they have electrons that can move throughout the material. Non-metals, all except the graphite found in your pencil, are poor conductors as they do not have electrons that can move. Graphite is the one non-metal that we talk about that actually does have electrons that can move, so can conduct electricity. Quick question. Why will this battery here never run out of its chemical energy store? Pause the video and have a think. This battery can never run out of its chemical energy store because it is not possible for any of its energy to be transferred by electrical work done, because it is not a complete circuit. There is a break. If this was a complete circuit, our battery would gradually reduce its chemical energy store as it transferred energy to the surroundings, because electrical work done would transfer energy to the light bulb, which would then transfer energy as light or heat to the surroundings, and the air around the bulb would gradually get warmer. Okay, that's it for the theory for this lesson. If you could log on to Microsoft Teams for me, there is a forms quiz waiting for you. You may wish to go back through these slides to help you answer them. I can see how long you've spent on the quiz, and I'd like you to spend a good 15 minutes on that quiz, really concentrating and flicking back through these slides if you get stuck. I will be available on Teams all lesson if you would like to chat or ask me any more questions. Take care, Year 8, and I'll speak to you soon. Bye.